Friends, there are two parts to the theory: the special theory of relativity and the general theory of relativity. The special theory of relativity, published by Einstein in 1905, tells us how speed influences time. If you are in a spaceship that is going very fast, if the speed is too high, time will slow down for you, relative to the people not on the spaceship, back on Earth. The word relative is very important because when you are in a spaceship, you wouldn't feel the time slowing down. You would think that time is flowing at the same speed as it normally does. But when you'll get back to the Earth, you'll find out that there was a difference in the flow of time. This is known as kinematic time dilation. And if you have seen my video on the time traveler, I have explained how this works in detail there. Not only speed, but even gravity can also result in time dilation, as shown by Einstein in his general theory of relativity. This was developed by him in 1915. The more gravitational force you'd experience, the more time would slow down for you. This is known as gravitational time dilation. And this was depicted amazingly in Interstellar. When Cooper and his team land on the Aqua planet, 1 hour on that planet equals 7 years on Earth. This happens on the planet because the planet was very close to the Gargantua black hole. So the gravitational force of the black hole impacted the time. To visualize this, Einstein wanted us to imagine a space-time fabric, kind of like a mesh on which all planetary objects are placed. The space-time fabric bends due to the mass of the objects. And when the mesh bends, not only does it attract physical objects more, but it leads to time dilation as well, and the other forms of energy, such as sound, heat, or light, they are affected by gravitation as well. If there are such objects, it means that they'd be completely black. We won't be able to see them, because not even light can escape them. Friends, this is exactly what black holes are. But when Einstein presented his theory of general relativity, the concept of black holes was merely theoretical back then. Einstein knew that gravitation influences light. And theoretically, objects that can absorb light were possible. But Einstein did not know that there are actual black holes. In fact, when Einstein was alive, the concept of black holes seemed weird to him. He knew that there can be such things, theoretically, but then, theoretically, the existence of infinity is also possible. But realistically, practically, he did not believe that such things existed in reality. By the time he passed away, not even the term black holes was invented. An interesting fun fact here, a key point in Einstein's theory, was that light's speed limits gravity's influence. We don't feel gravity's force instantly, everywhere. Its upper limit is the speed of light. To use a practical example, suppose that the sun disappeared suddenly. As you know, we'll get to know this 8 minutes later, on Earth, about the disappearance, because it takes 8 minutes for sunlight to reach Earth. But according to Einstein, the gravitational impact of the sun's disappearance will also be felt 8 minutes later. Isn't it very interesting? After Einstein, the theory of general relativity was worked on by many scientists. Like there were several equations, they solved those equations and tries to derive the solutions, and by getting to the solution of these equations, it was theoretically proven that things like black holes do indeed exist.